Now this is chapter 1, logarithms. We'll talk about just basic concepts. So we need to know what is the logarithm. A logarithm is a function, and in the truth, this function is just another expression for the exponential function. If you see this statement, you will find it in all the slides written inside this rectangle or inside this box, name it as you want. So this is now the expression that is called exponential. It is a power y equal x. So this statement is connected with y equal logarithm x to the base a in the relation of statement of if and only if. It means that those two statements are equivalent. We call this sentence the fundamental identity of logarithms. The fundamental identity of logarithms, this statement is a basic fact that we will use it in all the subjects of logarithms. For example, when we say 2 power 5 equal p, it's easy to multiply 2 by itself 5 times to get the value of p, which is 32. And when we say p power 3 equal 27, it is easy to write 27 after factoring as a 3 power 3. So then we will find the value of p, which is 3. But if we say 3 power p equal 5, it's so hard and cannot be solved using the exponential form. The exponential form cannot reach us to the value of p. That's why in such cases we go to this equivalent statements or the fundamental identity of logarithms, and we transfer from exponential form to logarithmic form and solve to find the value of the missing part. Now, the fundamental identity is this one. This part is called exponential form, and the equivalent part is called the logarithmic form. In both cases, we have a, we have x, and we have y. So what are they? A is called the base. A is greater than 0, and it has to not be equal to 1. This is some important condition about A. About x, we call it the argument. This argument means the value whatever inside the logarithm, and it has to be positive. It cannot be negative, it cannot be 0. Y is the number whose logarithm is taken, and it has to be a real value. Now, for example, if we look at example 1, write the logarithmic form. So I have the exponential form. I can transfer to logarithmic form using this fundamental identity. So if you see now, this is going to be 3 equal logarithm 8 to base 2. Here, 5 power 0 equal 1. So this is going to be logarithm 5. Logarithm 1 to base 5 equal 0. And in this case, we have a 3 power negative 2 equal 1 over 9. So then logarithm 1 over 9 base 3 equal negative 2. Also, we have other examples like example 2, write the exponential form. So given to us logarithmic form, want us to transfer to exponential form, we go to the fundamental identity. As you see, for making it very easy, we just look at 10 power 2 equal 100, and that's what's done here. 10 power 2 equal 100. 1 over 27 is the logarithm for base 3. This is a 3 power negative 3 equal 1 over 27. Also here 2 power 0 equals 1, and that's done. In example 3, we want to solve each equation for x. It is not just writing something. This is solving, means that we need to find the missing value. So now, logarithm 27 to the base x equal 3. I can't solve it unless I transfer it using the fundamental to the exponential value. So now x power 3 equal 27, and then by factoring 27 I will find that this is a 3 power 3, so x equal 3. The same thing here, 4 power 1 over 2 equal x. Here it is. Power 1 over 2 means the square root of 4, which is 2. So the value of x is 2. Again here, 16. So I have 4 power x equals 16. Thus I can just work with 16, make it as 4 power 2. So the value of x now is clear, 2. In example 4, calculate the logarithms. I have this logarithm, just logarithm 4 to the base 2. Want us to calculate it. So I need to make the value equal any expression, say y. Thus then 2 power y equal 4. And now I will solve using the exponential expression. Of course, 2 power y cannot be simplified, but 4 is 2 power 2, so then y is 2. Therefore, logarithm 4 to the base 2, which is given to us, equal 2. Now, logarithm 1 over 9 base 3. Also, I make it equal to any expression, say y. Then 3 power y equal 1 over 9. And again, 1 over 9 is 1 over 3 power 2, which is a 3 power negative 2, and y then negative 2. For this value, we have logarithm inside logarithm. So I have to finish the inner value first. The inner value is logarithm 9 to the base 3. Equal it to any expression, say m. Then this is a 3 power m equal 9. And now 9 is 3 power 2. That's why m equal 2. Now, instead of 3 logarithm 9 base 3, I will put 2. That's why the expression is going to be logarithm 2 to the base 2. So now the argument and base are equal, therefore the value is 1. And you can see it here. You can do it in other way, just like make it equal to any expression. And then 2 power n equal 2. And of course, I'm sure that you know that n equals 1. Example 5, we also want to calculate the logarithms. Here is my fundamental identity written in each slide. This is now the logarithm that is given. Logarithm 1 over 3 base 3. Equal it to y, then 3 power y equal 1 over 3. And of course, this is 3 power negative 1, then y is negative 1. Here, logarithm cubic root of 81 for the base 1 over 3. I equal it to y, and then 1 over 3 power y equal 81 power 1 over 3. So then, here, it's going to be 3 power negative y. I wrote it. And now, 81 is a 3 power 4. Since 3 multiplied by itself 4 times is 81. So this is a 3 power 4 power 1 over 3. Of course, I'm going to multiply the powers. This is going to be 4 over 3. Thus, 3 power negative y equal 3 power 4 over 3. So y is negative 4 over 3. Just transfer the negative. Now, logarithm cubic root of a multiplied by square root a. For the base a, maybe you feel that it is little complicated. Just we will solve it now, equal it to y. And now a power y equal the whole value here. As it is cubic root, so I will write it power 1 over 3. And when we multiply like bases, we add the powers. This is a power 1 and this is a power 1 over 2. So when you add them, they are a power 3 over 2. Just multiply the powers again, it is going to be 1 over 2, so the value of y is 1 over 2. Here we have logarithm inside logarithm inside logarithm. So we will start from the inner value. Take it here. Logarithm 81 base 9 equal it to m. Of course, this is 9 power m equal 81. 81 is 9 power 2, thus m equal 2. So this value now all is 2. Again, now this 2 with this 2, this is a new logarithm. Logarithm 2 base 2 equal n, and we know that it is 1. Then 1 for this logarithm, logarithm 1 base 3, say equal t, for example. So this is a 3 power t equal 1, and then t is 0. And both two values here, we can find them from the properties also. Nextly, we will see them. So the final answer for the whole 3 logarithms, one inside one, is 0. Now on example 6, we also have our fundamental identity. We cannot leave it, but we will reach a new relation which is already found here, saying that a power y, okay, equals x. Thus if and only if y equal logarithm x to base a. So if we replace this value y by this value, what equal to it? It's going to be a power logarithm x base a. Thus equal x. Here it is. Means that if you have a base a raised to logarithm with the same base, you see the like bases, so the final answer is just the argument x. Now we will do it here. For example, 2 raised to logarithm I'm sorry, 2 raised to logarithm 8 power base 2. So now the bases are like. The big one and the small one both are like. So then the final answer is 8. Now, here we can also, if you don't know how to solve it directly in this way, we can just take this exponent, logarithm 8 base 2, equal to n, for example. Then 2 power n, I'm sorry, 2 power n equal 8. So this is 2 power 3, and then equals 3. If you substitute this n here instead of log, it's going to be 2 power 3 equals 8. Take here 25 raised to logarithm 3 base 5. Now this 25 is 5 power 2. This exponent logarithm 3 base 5, we will make it equal t. So this complicated expression is going to be 5 power 2 power t. What if you replace them? It is possible because you are using the commutative property, and then put t back to its real value, logarithm 3 base 5. Now look at the bases, they are equal. So this is all equal 3 power 2, which is 9. Again here, 3 raised to a power. This power is a 3 multiplied by logarithm 2 base 3. I will make this value of logarithm t. Here it is. So the power is going to be 3 power 3 times t, which is here. Now put t inside parentheses and get 3 out in the powers. This is properties in multiplication. So now t back to logarithm 2 base 3. Look at the bases now. They are equal. So they are now equal to, and this is 2 power 3, which is 8. Now you have in the book some exercises given, check yourself, you can solve them.